So, how are you guys doing today? I want to go over briefly about combining like terms when we add and subtract polynomials. So, this is a topic coming up here for concept 1B for unit 7. So, let's just remind ourselves, what does it mean when you have like terms and combining like terms? So, in your notes, you should remember, well, actually, why don't we pause right quick and what do we mean by like terms? So as you filled in your answer on Edpuzzle, let's remind ourselves like terms have the same variable with the exact same exponent. So in this case, this term here, 5x squared, its term is x squared. This term, 8x, has an x, but it doesn't have an x squared. Its exponent is just 1. So therefore, they don't have the same exponent. He's not a like term. And so, but over here, we do have a 4x squared here, and those would be like terms. Same thing, we talked about this 8x to the first power. Remember, if you don't see an exponent on a variable, the exponent is 1. And so these guys who both have x to the first power, they're like terms. And then these guys right here at the end, -2 and -5, those are the constants. They don't have any variables. And we can combine those. So why don't we give a moment, let's give you a chance to combine those on your own. And we'll come back in a couple of seconds. All right, let's go ahead and now let's combine these like terms for example 1. Let's see what you came up with. If we combine the 5x squared with the 4x squared, since we said those are both like terms, as we combine those, we'll get 9x squared. As we combine our next set of like terms, this plus 8x and the plus 9x, as we combine those two, we will get 17x. And when you combine the -2 with the -5, be careful of your negatives. Negatives are super important. We'll see that's going to give us -7. So let me tilt that a little bit more here. So hopefully you're able to see how when we combine like terms, we're able to get 9x squared plus 17x minus 7. Can we simplify it any more? Hopefully you answered no, because there are no more like terms, and so this is our final answer. Why don't we pause here, take a moment to copy this down, and why don't you give example 2 and example 3 a try by yourself, and then we'll come back and we'll look at those answers later. Okay, now that you tried those answers, let's take a look at example 5. Same page, unit 7, concept 1B. So this one reads, I see this little glare there, so make sure you're reading along with your packet. It says subtract 5x minus 8 from 4x plus 1. Now there's 2 great tips on that page, so go ahead and take out your packet. Let's read them together. One of them is the negative sign really matters. And we put that next to example 4. I'm going to go back and let you do example 4 on your own. But we're going to talk about why that negative sign really matters. And the second hint is the from. This from you see here, let's put this in quotes so you can see it. When you see this from, the from term always comes first. So matter of fact, and it both starts with F. So when you see from, I want you to think first. So what does that mean? Subtract 5x minus 8 from 4x plus 1. Let's put parentheses. I like to put parentheses around polynomials. Helps me separate them and talk about them together as a group. So we have our 2 binomials here. So why do we say from is first? Notice they both start with F. When you write this out and rewrite it, you're going to put the 4x plus 1 first. So this is 4x plus 1. what you're subtracting from is going to go first. So it's 4x plus 1. Then we're going to subtract the 5x minus 8. Go ahead and hit pause and copy down that first step. The next step from here, when we talked about this negative sign really matters, it makes a huge difference. Though we don't see it, remember we talked about what number is there? If you don't see a number right outside of parentheses, there's a 1. So actually we have a negative 1 being multiplied by this first term, this 5x, and the negative 8. That negative 1 is going to change the sign of each of those terms in the parentheses in the polynomial following it. So let's see what this looks like again. So now we're going to have a 4x plus 1. I'm going to drop the parentheses now. I'm going to go ahead, negative 1 times that 5x is going to give us negative 5x. And negative 1 times negative 8 is going to give us a positive 8. Once again, the negative sign really matters. Don't make that mistake. Put a star on it right now to remind yourself. This negative sign is going to go to each of the terms in the parentheses it follows, changing both of the signs. So you see this 5x is now minus 5x, and that negative 8 is now plus 8. That's huge, because now we go to our next step, and remember we're going to just group our like terms. Who are our like terms? The ones that have the exact same variable with the exact same exponent. So I have the 4x minus the 5x. Like terms, negative sign, hugely important. So notice they're going to stay together. And then we're also going to have the plus 1 and the plus 8. Hope I'm not running out of space over here. Yep, I think I fit that in there. Notice the constants we talked about. They have no variable there together. And so when we combine our like terms, 4x minus 5x, remember you're combining just the coefficients here. 4 minus 5, that's a negative 1x. And of course, we could just write that as negative x if you wanted. So sorry, let's tilt that down a little bit. And the plus 1 plus 8, that gives us plus 9. So we wind up with negative 1x plus 9, or we could just say negative x plus 9. Alrighty here. So this is how we do some adding and subtracting with binomials. Hit pause. Try example 4 on your own. Make sure you remember that negative sign really matters, and that negative sign is going to change the sign of each term in the parentheses that's following it. And give some of these a try on your own, and I hope you're successful. See you later in class.